Hi, today we are starting our Unit 6 Inference for Categorical Data Proportions. This will be our Chapter 8 Inference for One Sample. We learned if we randomly select the sample, we should be able to generalize our results to the population of interest. We also learned that different samples yield different results for our estimate. In this chapter, we'll learn one method of statistical inference called confidence intervals. So we may estimate the values of a parameter from a sample statistic. As we do so, we'll learn not only how to construct a confidence interval, but also how to report probabilities that would describe what would happen if we use the inference method many times. Our learning targets for this section are how to interpret confidence interval and confidence level in context, use confidence interval to make a decision about values of a parameter, and then describe how the sample size and confidence level affect the margin of error. Remember that point estimator is a statistic that provides an estimate of a population parameter. We previously learned that an ideal point estimator will have no bias and low variability. Since variability is almost always present when calculating statistics from different samples, we must extend our thinking about estimating parameters to include an acknowledgement that repeated sampling could yield different results. So the value of a point estimator from a sample is called a point estimate. Confidence intervals gives a set of plausible values for a parameter based on a sample data. This interval that is calculated from the data will have a margin of error that tells us how close the estimate tends to be to the unknown parameter in repeated random sampling. So we would have the point estimate plus or minus the margin of error. There is a specific way for interpreting a confidence interval for an unknown parameter. And the way we write it is we are C% confident that the interval from the starting value to the ending value captures the true value of the population parameter in context. You do need to be very careful to describe the parameter and not the statistic. So, for example, if we write, we are 95% confident the interval from 0.436 to 0.466 captures the proportion of U.S. adults who said they volunteered in the previous 12 months. This proportion who said they volunteered in the previous 12 months, is the sample proportion and not the population. So remember, the interval gives plausible values for the proportion of all U.S. adults who would say they have volunteered in the previous 12 months. So it is very important that you describe the parameter and not the statistic. Let's practice interpreting confidence interval from context. The National Health and Nutrition Examination Survey is an ongoing research program conducted by the National Center for Health Statistics. Based on a random sample of 500 U.S. residents of age 8 and older, a 95% confidence interval for the mean systolic blood pressure, the upper number in blood pressure measurement is 119.6 to 123.6 millimeters of mercury. Let's identify the confidence interval. So when we read this problem, the confidence interval is 95%. Let's identify what the population is here. It's not the 500 U.S. residents, it is all U.S. residents. So all U.S. residents age 8 and older. And again, this is all. Now let's identify the range that they gave us. So the range here is 119.6 to 123.6 millimeters of mercury. So from there, let's make sure that we know how to write it. So we're going to interpret the confidence interval. So we would say we are 95% confident that the interval from 119.6 to 123.6 millimeters of mercury captures the mean systolic blood pressure of all U.S. residents age 8 and older. Let's use the confidence interval to justify a claim. Remember that confidence intervals are intervals of plausible values for a parameter. When a claimed value for the parameter falls outside a confidence interval, there's convincing evidence that the true value of the parameter is different from the claimed values. We're going to use the previous example, and we're going to use our confidence interval that we just found to see if we have convincing evidence for a claimed value here. So it says, according to the Center of Disease Control and Prevention, normal systolic blood pressure is less than or equal to 120 millimeters of mercury. Based on this interval, is there convincing evidence that the mean systolic blood pressure of all U.S. residents age 8 and older is greater than 120 millimeters of mercury? So if we're looking at that it has to be greater than 122 millimeters of mercury, and if we look at our interval was 119.6 to 123.6 millimeters of mercury. Notice that those values are within that interval. So 120 is within that interval, and there are values that are smaller. So the way that we would explain our reasoning, if this is a convincing or not convincing claim, we would say because there are values in the interval from 119.6 to 123.6 that are less than or equal to 120, there is not convincing evidence that the mean systolic blood pressure of all U.S. residents age 8 and older is greater than 120 millimeters per mercury. Now remember that the confidence interval gives plausible values for the mean systolic blood pressure, not the blood pressure of an individual resident. So that's important. Now that we understand confidence interval, let's understand what confidence level is. That is, in C% of all possible samples, the method would yield an interval that captures the true parameter value. The confidence level is the overall capture rate if the method is used many times. We usually choose a confidence level of 90% or higher because we want to be quite sure of our conclusion. The most common confidence level is 95%. Now, how are we going to interpret confidence level? Remember that repeated sampling could yield different results. So the way we interpret a confidence level is by saying, if we were to select many random samples of the same size from the same population and construct a C% confidence interval using each sample, about C% of the intervals would capture the parameter in context. So if we look at this here, this red dot is our point estimate, and this is our margin of error where we're adding and subtracting. This is our parameter in context. Our parameter is mu here. So if we notice 95, if we say that it's 95%, 95% of the intervals would capture that particular parameter. Notice some of them will not, and that's okay because we're just saying a particular percentage. So about that percentage of those intervals would capture that parameter. Let's practice with interpreting confidence level from a given scenario. We learned that 95% confidence interval for the mean systolic blood pressure of all U.S. residents age 8 and older is 119.6 to 123 millimeters per mercury. Remember that from a repeated sampling, it could yield different results. So the way we're going to interpret the confidence level is if we were to select many, so that it's very important that you write many, random samples of 500 U.S. residents age 8 or older and construct a 95% confidence interval using each sample, about 95% of the intervals would capture the mean systolic blood pressure of all U.S. residents age 8 or older. So notice we talked about collecting our sample and doing it many times, and we're constructing different intervals. And then we're stating 95% of those intervals that we've created would capture the mean systolic blood pressure of all U.S. residents, which is our population there. Remember that the interpretation of confidence level are about the method used to construct the interval and not one particular interval. That's why we talk about many random samples here. It does not tell us the probability that a particular confidence interval captures the population parameter. So make sure it is many random samples of that particular confidence interval. Now make sure to read the AP question, because on a given question, they can ask you to interpret the confidence interval, the confidence level, or both. You do need to make sure that you understand the difference between them. Confidence interval gives a set of plausible values for the parameter, so different intervals. And the confidence level describes the overall capture rate of that method. So confidence levels tells us how likely it is that the method we are using will produce an interval that captures the population parameter if we use it many times. The confidence level does not tell us the chance that a particular confidence interval captures the population parameter. The confidence interval gives us a set of plausible values for the parameter, and we interpret confidence levels and confidence intervals in much the same way, whether we're estimating population mean, proportion, or another parameter. In this unit, we're going to focus on proportion. And these, looking at the margin of error and what factors affect it, in general, we prefer an estimate with a small margin of error. The margin of error gets smaller when the confidence level decreases. To obtain a smaller margin of error, we must be willing to accept a smaller capture rate. And the sample size n increases, then it reduces the margin of error for any fixed confidence level. Let's see how we can interpret how certain factors affect the margin of error in a problem. In the self-flowing example, we were 95% confident that the interval from 0.2 to 0.261 captures the true proportion of all cell phone users who would admit to walking into something or someone while talking on their cell phone. The interval was based on a random sample of 738 cell phone users. Explain what would happen to the width of the interval if the confidence level were to increase to 99%. So we are changing it from 95% confidence interval, and we're increasing it to a 99% confidence interval. So the confidence interval would be wider because it increasing the confidence level from 95 to 99% increases our margin of error. So to be more confident that our interval captures the population, we need a wider interval, which requires a larger confidence interval, which we're going to end up calling critical value in our next section. In the same situation, what would happen if we increased the sample size? So we're increasing from 738 cell phone users to 1,500 cell phone users. So if we increase the sample size, that means that our confidence interval would be narrower, because increasing the sample size will decrease the margin of error when everything else stays the same. So remember, increasing the sample size decreases the standard error of the sampling distribution, which we will find out how to find it in the next section. And remember, very important, the margin of error does not account for any sources of bias in the data collection process. It does not account for any bias. As we wrap up, these were the important learning targets for this section.